So this is the second video to section 2-3, so it's section 2-3 continued, and our topic is biconditionals as definitions. So in section 1-2 we talked about undefined terms like point, line, and plane and how they are the building blocks of geometry. And so even though they're undefined, we understand the meaning of these terms intuitively. And so then we can use them to define other terms like segment. A good definition is a statement that can help you identify or classify an object. So good definitions have a couple of different important components. One of those is that a good definition uses clearly understood terms. These terms should be commonly understood, or you should have them be already defined. So they say commonly understood because we want to make sure that we can include using words like point, line, and plane that we haven't defined yet. A good definition is also precise. So it avoids using words like large, sort of, almost, because it doesn't give us a good idea of what's happening. We get a lot more specific using measurements, congruent, that sort of thing. A good definition is also reversible. And so that means you can actually write a good definition as a true biconditional. And that's what we're going to talk about today. We're now going to do an example of writing a definition as a biconditional. So the definition that we're given here is a quadrilateral is a polygon with 4 sides. So the steps that we're going to use to see if this is a good definition, if it's a reversible, is we're going to write it out as a conditional statement, as the converse of that statement, and then we'll write it out as a biconditional if it's reversible. So, the conditional version of this statement is, if a figure is a quadrilateral, then it is a polygon with 4 sides. So now we're going to take the converse of that statement, and that's where we switch our P and our Q, so we switch our hypothesis and our conclusion. And so the converse of this statement is, if a figure is a polygon with 4 sides, then it is a quadrilateral. And we find that this is actually true. So our statement is reversible, so now we can go ahead and write it as a biconditional statement. Our biconditional statement is, then, a figure is a quadrilateral if and only if it is a polygon with 4 sides. So our statement was reversible, and therefore we have a good definition of what a quadrilateral is. All right, now it's time for some practice problems. So our problem that we're going to try here is we're given the definition, a straight angle is an angle that measures 180. So our goal here is we're trying to find out if the statement is reversible, and if it is, we want to write it as a true biconditional. So your first step is that you're going to write it out as a conditional. You're going to write out the converse of that statement and decide if the converse is true. If it is, then our statement is reversible, so you can go ahead and write the biconditional of our statement. So go ahead and pause the video, write out the conditional, the converse, and if the converse is true, then write out the biconditional as well. So now that you've had a chance to work on this on your own, we'll go over it together. So our definition was a straight angle is an angle that measures 180. So our first step is to rewrite this as a conditional. So we can say if an angle is a straight angle, then it measures 180. And then the converse of that is going to be, we're just going to switch our P and our Q. So we're going to switch our hypothesis and our conclusion. So if an angle measures 180, then it is straight. And it turns out that converse is actually true, so our statement is reversible, so now we get to write the biconditional. So the biconditional, remember, is the if and only if statement, so the biconditional is going to be an angle is a straight angle if and only if it measures 180. And there's our biconditional.